In the last mini-lesson, we began an exploration of the problem-solving strategies involved in analyzing impulsive motion, or more specifically, collisions and explosions. After briefly reviewing the underlying concepts and principles, we applied them to an example involving an inelastic collision in one dimension. In this mini-lesson, we continue that exploration through a somewhat more involved example, in which we will need to analyze the motion during two consecutive segments in order to solve the problem. A 12.0 gram wad of sticky clay is hurled horizontally at a 100 gram wooden block, which is initially at rest on a horizontal surface. After impact, the block, with clay stuck to it, slides 75 centimeters before coming to rest. If the coefficient of kinetic friction between the block and the surface is 0.650, what was the speed of the clay wad immediately before impact? This problem is delimited by three distinct events. Event 1, which is before the clay and the block collide, Event 2, which is immediately after the collision, and Event 3, when the block comes to rest after sliding. Let's sketch all three events in turn. Before the collision, the wad of clay is approaching the stationary block at an unknown velocity v1. Immediately after the collision, the clay has stuck to the block, and the combined object begins sliding along the floor at unknown velocity v3. And finally, after sliding 75 centimeters, the object comes to a rest. Since the quantity we're asked to compute, v1, is associated with the first event, it seems sensible to work backwards, starting with the sliding motion and then relating that to the collision. So first, the sliding motion. We're given the final velocity, v4 equals 0, and we wish to compute the initial velocity, v3. There are several approaches we could choose, but let's go with the work kinetic energy theorem, which says that the change in kinetic energy is equal to the total work done. The only force that does work is kinetic friction, mu sub k times the normal force, or mu sub k times mg, since the normal force has to equal mg in this problem. Since the frictional force opposes the motion, it does negative work, so that the work W is equal to minus mu sub k times mg times delta x. Therefore, the final kinetic energy minus the initial kinetic energy is equal to the work, which is minus mu sub k mg delta x. Of course, the final kinetic energy is 0, since the block has stopped. Solving for the initial velocity of the sliding motion, which is v3, and plugging in numbers gives v3 equals 3.09 meters per second. The initial velocity of the sliding part of the motion is the same as the velocity right after the collision. So now we can apply momentum conservation to determine v1, the velocity of the clay wad before the collision. The total momentum before the collision is the momentum of the clay plus the momentum of the block. The latter is 0 since the block starts at rest. Thus, the total momentum before the collision is m sub c times v1, the initial momentum of the clay wad. This has to equal the total momentum after the collision, which is m sub b plus c times v sub 3, the momentum of the clay-covered block. Solving for the unknown gives v1 equals m sub b plus c divided by m sub c, that quantity times v sub 3. And plugging in numbers, we find that the velocity of the clay wad before the collision was 28.9 meters per second.